Deep below the surface, atomic compounds ignite during volcanic activity to form CO2. The gas is born from the pressure created by the heat of molten rock, or magma.
It rises towards the surface and reaches the summit magma storage complex. The pressure is decreased on the magma. And the effect of that is to allow gases that are trapped under the very high pressure to be released and bubble out.
The Venusian surface would likely have cracks in the lava similar to these vents, where gases escape into the airstream.
Somewhere between 8,000 and 30,000 metric tons of carbon dioxide boil out of the magma chamber each day. And it amounts to something on the order of 3.5 to 5 million tons per year.
And that's just one volcano here on Earth. Venus has more active volcanoes, and that means more heat-bouncing gases.
So all the CO2 just builds up in the atmosphere on Venus, which just makes it hotter and hotter.
The 900-degree heat isn't the only trait that makes Earth's twin seem a menace. 30 miles above the scorching ground of Venus, there's havoc occurring on the planet that makes 900 degrees Fahrenheit feel like a cold front. Electrical mayhem, where split-second jolts can reach 50,000 degrees. Each spark of light contains 100 million volts of electricity. Lightning occurs on both Earth and Venus when electrical charges store up enough energy until they release a spark. Mears Oppenheim teaches planetary physics to students at Boston University. And researchers like him get in on the action at Boston's And then it's showtime.
So look at this. We're generating so many millions of volts on these domes that voltage
they provide that spark.
These are particles that come from way out in the universe into the atmosphere and cause a shower of charged particles. And on Venus, you'd probably have real lightning to the extreme extent, contain enormous amounts of energy, and go for miles and miles.
On average, lightning hits the Earth more than 3.1 billion times a year. The number of times lightning hits the ground on Venus? 0. The atmospheric pressure on Venus is 90 times greater than on Earth because the weight of the atmosphere created by gases is heavier. This prevents Venusian lightning from hitting hard ground. Instead, it is restrained to the clouds.
There's just too much resistance in that very thick air for a lightning bolt to get through. It's much easier for lightning to discharge from cloud to cloud.
And besides appearance, there's little else that's Earth-like about Venusian clouds. In fact, the main ingredient that creates them is toxic enough to burn through human flesh. From Earth, you might be able to see Venus twinkle in the morning and evening skies like a star.
Definitely not a wallflower. It's so bright in our sky, not just because it's the closest planet to us, but because it's the most reflective planet. Because it turns out Venus is completely covered in these bright reflective clouds.
80% of the sun's light bounces off the clouds that blanket the planet. But even in the clouds, Venus, our so-called twin planet, manages to show an evil nature.
And we know that the clouds of Venus are made out of sulfuric acid, basically like battery acid. And that sulfuric acid is made by sulfur dioxide coming out of volcanoes on the surface.
Like its greenhouse cousin, carbon dioxide, or CO2, gas pressure pushes sulfur dioxide to the surface through volcanic vents. It's the same gas chemists